Loading. 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 Hi, everyone. Thank you for joining us today. We'll be starting in just a couple minutes. Hi, everyone. As you're joining, feel free to share where you're tuning in from today. You can do so right in the chat. This part is always really exciting to just see the global reach of our attendees. Awesome. Wonderful. And we'll be starting in just about a minute. All right. Hi, everyone. So we're at the top of the hour, so we're going to go ahead and get started. We're really excited for today's session. As an introduction, I'm Sally Poppers with Scrum Alliance. Thank you all for joining us today for our presentation, Essential Technical Capabilities for Activities for Successful Incremental Software Development. During today's hour-long session, we'll explore the core 4 technical practices, including diligent refactoring, test or behavior-driven development, continuous integration, and pair programming, as well as the dynamics amongst them. This webinar is part of the Continuous Improvement series, where presenters share their expertise and highlight the tools available to Scrum Alliance certificate holders through comparative agility. Today, we'll learn about the Essential Developer Capabilities Assessment, which was developed to provide organizations and their teams with the ability to create, maintain, and deliver quality software products. This assessment is free to certificate holders and accessible through your member dashboard. And we'll send instructions for accessing this tool after our presentation. A few items before we get started. All of our webinar participants will be in listen-only mode. At the end of the presentation, we'll have a question and answer session. So please submit your questions in the questions chat box, and we'll address them at the end of the session. Also, this webinar is being recorded and will be posted on our Scrum Alliance website after the event. So I'd now like to go ahead and introduce our speakers, Jorgen Hesselberg and Rob Myers. Jorgen is the author of Unlocking Agility and co-founder of Comparative Agility, a leading agile assessment and continuous improvement platform. He'll be sharing about the comparative agility tools that are available to Scrum Alliance certificate holders. Rob Myers has 35 years of professional experience in software development and has been mentoring teams in agile techniques since 1998. His courses blend fun, practical, hands-on coding labs, advanced learning techniques, and relevant first-person stories from both successful and not so successful agile implementations. Thank you both for joining us today, and welcome.
Thank you so much for that, Solly. And Rob, let's take over here and get this party started. Really excited about this session. I think we don't do enough when it comes to technical practices, and now we're finally doing that. So that's something I'm really excited about. So I'm going to stop sharing my screen, Rob, and then see if you can pick up your Miro board here. A couple of things I just want to mention real brief. First of all, yes, there is a premiere right now. The new assessment is out there, and that assessment is something you can start using right away. It's called Essential Developer Capabilities. Just go to comparativeagility.com and you can test that out right away. Great session that you can try for your teams. Another thing that's great to know for those of you who are Scrum Alliance members is that depending on your membership level, you get free subscriptions. And the way you activate those subscriptions is pretty simple. Go to your dashboard at scrumalliance.org. And if you go down one more item there, Rob, you see there's a little member benefits, little square. You click on comparative agility, then you will activate your membership, and then you have a free membership depending on your certificate level. So enough about that. Let's get over to the main guest. That is the main course, which of course is Rob Myers. This is a person that I've known for many, many years. He has helped me. He has helped my teams. He's one of those people who combines deep technical skills with empathy, which very often is something you can't find, but this guy has it. So take it away.
Thank you, Jorgen. Hey, Jorgen, what time is it there? I was just curious.
In Norway now, it's about 7 o'clock. 7.
All right. All right. Well, here it's 10 in the morning, so good morning and good night and etc. to everyone. So I'm going to start out by talking about the ideal Agile team, or what we think is the ideal Agile team. There's this problem that we have with some Agile teams, and I have a name for it. So let's just look at this little thing here, this little diagram. I'm going to zoom in a little bit. Hopefully, don't make anybody too seasick here. But when a team starts out, greenfield project, or even a non-greenfield project, a project that's in flight, often Scrum teams will find that they start out and everything seems pretty cool. They're doing something new. They're having a lot of fun, and they're doing their sprints. And in the first sprint of a project, they find that they're able to complete their PBIs, and everybody's happy. And you see the little all the smiling faces over here. Everybody's happy. Everything's cool. We've got a couple of PBIs done. It's pretty straightforward. There's a UI, there's a database, and they're talking to each other, and everything's great. And that goes on for the first few sprints, and things are getting a little more complicated, but things are looking pretty good. No problems there. All right. And then things keep getting a little more complicated, and for the most part, things are going pretty smoothly, but there is that one little unhappy guy here. He's saying to himself, I did not get my PBI done this sprint, or it's getting a little bit more challenging to get anything accomplished. Right. And after a certain point, maybe about five or six sprints in, I see somebody said, I said PBI, not PDI, product backlog item. Sorry about that. Product backlog item or user story is one of the other terms that we might use for that. And after a certain point, 5 or 6 sprints in, and it doesn't seem to matter how long the sprints are. They could be a month long, they could be a week long. It seems like people start to notice something going on here. There's a lot of complexity to the system, and as you see, there aren't any happy people anymore. So they're just not sure that this whole Agile thing is going to work out for them very well, right? And sometimes they abandon Agile, sometimes they try to fix it in weird ways. Anyway, it's not good. Okay, so see if I can get back to frames here. I call this the Agilist Dilemma. What this is that exact feeling that we have, that we've set up our situation where we're doing incremental and iterative development, and we're producing just enough software, we're producing just enough value, we're producing doing just enough testing to get the product backlog items out the door. However, what we're doing is starting to feel a little bit painful. And software developers know this. What they experience is that it gets more and more difficult to do the same amount of work to the system. And the reason why is because a professional software developer knows that when they change something, they might break something. And we have this perception with software development, especially with Agile software development, that we're creating thin slices through the software, right? And that's really what we want to do. However, software doesn't really lend itself to sort of stovepiped thin slices. It tends to do something a little bit more like this. In other words, as you're working on the software, as you're building more and more of the software, the more critical parts of the software, the more critical layers, if you will, are the ones that go through the most change. And this is sort of the opposite of what we had expected when we were doing waterfall systems. Is that we plan everything up front so that nothing could possibly go wrong, and we discovered that that wasn't true. Well, now here we find that the things that we want to stay stable are the least stable in the system, especially at first, until they settle in, until they're interoperating with 4 or 5 of the other parts of the system. Then they'll start to settle down. But especially early on, things like database access or network access, things that are getting used by everything, tend to go through the most churn. One other example is your database schema, right? People want the schema to be planned out all up front and in advance, and that's just not going to work. That's the thing that churns the most. So we have this assumption that we're going to be developing iteratively and incrementally, and yet we discover that that's more and more of a challenge. Now, it's not only true for software developers, it's also true for the testers. They're finding that they can test, especially at the beginning, they're testing just those PBIs that have been built and everything's fine and everything's working. What they discover after 5 or 6 sprints is that not only do they have to test the new user stories, they also have to test all of the previous user stories. And on a project that's been running for 2 years, that's a lot of effort. And so they're running into these challenges as well. This is the Agilist dilemma for them. Here's the situation is that we have offered a way of managing our software delivery in such a way that it is incremental and iterative. However, we have not changed any of our engineering practices, any of our software development practices. And if we don't do something that's iterative and incremental regarding software development, we're going to run into the exact same problems that these teams are running into. So something else has to change, and that's when we get into the core four here. Let me talk just a little bit about each one of these, and then we'll talk about the diagram on the right. Okay. So test-driven development, behavior-driven development, these are test-first practices. That doesn't mean you write all your tests first, by the way. It means you actually handle one test at a time. So whether you're doing a unit test or whether you're doing a behavioral scenario, an example of a piece of functionality, you're essentially churning through it one at a time and actually getting it to work before you move on. Now, you being, a developer or a BA or a QA or product owner, whoever's working on that test, you get that test running, you get it failing, and then you get it passing. And obviously there has to be a software developer sitting next to you in order to get that to be completed. So that's a very unusual and sort of uncomfortable practice for a lot of people at first. However, it becomes fairly natural over time. And this test-driven development and behavior-driven development both are, I like to say that they are the way that we build the safety net of tests that protect our investment in the software. So, we think testing is good, but these practices are not really testing until the test passes. Then it's a test. Before then, it's a specification. So these practices, test-driven development, kind of a funny name for it, but it's sort of specification-driven or example-driven. And we end up leaving behind a safety net. So it's not just the test itself that prevents defects or misunderstandings. It's the whole collection of tests or scenarios that you're writing that provide that safety net for understanding and also for quality. Okay. Refactoring is another one of these core practices. This is not rewriting the code. It's not deleting and starting over again or anything like that. It's reshaping the design of the software to meet reality, to meet the requirements that have been specified in those tests, and also to reshape it so that it can absorb new requirements, new PBIs, user stories, however you want to look at that. So if first example, today, let's say that your software is perfectly well designed for all of its features. Tomorrow, when some new feature request comes in, that is exactly the time where things are going to have to change by definition. And fortunately, a good design is a changeable design. So we reshape the design to meet the PBIs that are hitting you in the face. They're coming right at you. They're in your sprint. Okay. Continuous integration is the essentially keeping things the document of record in one place. In other words, you keep one branch, one long-lived branch in your repository for the code, so that it's the source. It's the place where you go for, what is the source of truth for our software? What's working, what's shippable, and what's not, right? What's not is not in there. And teams that are doing continuous integration are, no surprise, continuously integrating, which means they're making small changes multiple times per day, and they're integrating into the trunk. This is everybody on the team. So if you have 4 pairs of software developers, they're probably going to be integrating, let's say 6 to 10 times per day. Of course, you say, oh, merge conflicts. Not so much, because after time, if the change is small enough, then the small incremental changes fit right in. Okay. Pairing and mobbing. Also known as ensemble programming. So pairing, mobbing, ensemble, I need to change that. We call it mob programming in the US, and I like the term ensemble programming as well. Pairing is 2 people working together, usually 2 software developers working together. You could also be doing, if you're doing behavior-driven development, you might be pairing with a tester or a BA. Mobbing is actually this notion of the entire team coming together and working on one thing at a time. Sounds horribly inefficient, but it's amazingly efficient. It's great for communication. It's great for making sure that there's understanding around every single topic. It's great for cross-training. Everybody understands what the software does. So those are the core 4 practices. Now, thinking back to the Agilist Dilemma, remember, we have this situation where we need to be doing something differently because we have these short sprints, because we're changing things, and then we're changing things again, and we're constantly changing things. So the question I'm going to pose to you, and Solly is going to put up a survey, is, there's the survey. Which of these core 4 practices is most directly responsible for resolving the Agilist's dilemma? And I'll tell you, there are no wrong answers, but you know, oh, panelists and hosts can't vote. I was about ready to vote, but that's good. There are no wrong answers, but there's one answer that I seem to describe as the heart. So if you want to, you can guess what I would say. Ah, okay. So CI wins out. It often does. And that is a good answer. It's not the answer I usually give, though. And it's not that it's not important. It's extremely important. But you'll see. What I put here, these, I mean, we've narrowed it down to 4, so obviously they're all 4 very important. However, there is one that stands out for me, which is refactoring. The ability to refactor the code, to reshape it so that you can introduce new extensions, new features, that is at the heart for me. And all of the others are supporting that very closely. So we have test-driven development, which is creating the safety net that makes refactoring possible and easy. And, it's easier to be courageous when you have a safety net under you protecting your investment. And then the others, of course, are all supporting. So this is how I draw it. Now, so test-driven development is building the safety net. Continuous integration is an interesting thing because if, and by the way, just to talk about a relationship between CI and mobbing here, if you're mobbing, you don't necessarily have to, you want to integrate continuously, but there's never a merge conflict, right? Because nobody else is working on the code. Interesting fact there. But with continuous integration, if you're not taking the changes that you're making to the system, whether those are refactorings or additional tests and functionality, and giving those out to the rest of the team, then the rest of the team cannot use those and nobody refactors. Nobody can refactor because if we have 2 branches and they're long-lived branches, and one pair is doing massive changes on there and the other pair is doing their massive changes for their features, and then they try to integrate at any point after a couple of days, they're going to have a mess. So this is why continuous integration is definitely supporting refactoring. And pairing and mobbing, it's the kind of thing where, since refactoring really is the design phase, if you will, of agile software development. It's not a phase, obviously. It's something where we're spreading over like jelly. We're spreading it out all the time. We're constantly doing all of these. Since refactoring is the design activity of an agile software development team, then it behooves you to be working with somebody else, because I got to tell you, 30 years of software development, when I write code by myself, I usually create garbage. Even now with a new programming language or something like that, I don't have somebody sitting next to me telling me, hey, there's actually a better idiom for that, or hey, there's a library for that, or I just don't like the way you named that. I don't understand it. So if you have one other person looking at it, what do you have? You have basically a continuous code review, right? So if you think code reviews are great, let's turn up the volume and do them all the time. And that's essentially what's going on with pairing. So pairing and mobbing definitely, definitely support refactoring. These also have relationships amongst themselves. The little dotted gray lines here, I already talked about continuous integration, pairing and mobbing, and test-driven development and continuous integration. These tests, every single time you get a test to pass, it should go into the integration pool essentially as a test that needs to continue passing. Like I said, once it passes, it's a test. And once it's a test, it's a regression test. So the continuous integration server, or if you're doing it manually, it should pass. And the instant one of these, a single unit test or a passing scenario, starts to fail, those changes should not get integrated, right? They should be kicked back to the team and say, hey, this isn't working, so we're not going to merge this. Let's see, have I missed one? Yeah, pairing and mobbing and test-driven development. I can't even separate those two anymore. I just don't know how to do one without the other anymore. Maybe that's just me and my history, but I like working with somebody else, and especially with test-driven development, since you are doing both implementation and unit testing. It's nice to have somebody with you to sort of keep track of the bigger picture as you delve into the details of, okay, how am I going to write this code so that it makes this test pass? So there's sort of two mentalities that are going into software development here, and so the pairing and mobbing supports test-driven development and behavior-driven development. Okay. Whoops. Let's see here. Having a little bit of a Miro dysfunction here. Oh, yeah, that's essentially the whole thing except for Q&A. So I like to keep these things short, and then I like to chat with people. So I'm gonna go ahead and put up my contact information, and I don't know. Should I stop sharing the screen or just leave that up? Solly, what do you think?
I think you can leave it up. Thank
Okay.
you so much, Rob, for that presentation. And I guess we can go ahead and get into the Q&A. So I have a couple questions I've already received in the Q&A chat box here on Zoom. But if you have more questions, please feel free to go ahead and add them, and we'll get to them at the end of this time that we have together.
I just realized too that I was going to share the link. So I'm going to share that in chat just in case anybody needs it or wants it.
Awesome. Yes, that's a great reference. So actually,
links. Go ahead.
Okay, a question just came up in the chat box. We can start with this one. It says, could you summarize the Agilist Dilemma in more detail? I don't fully understand it yet.
Yeah, the Agilist Dilemma. It's something that I noticed when I started coaching teams. I was very fortunate when I was doing Agile software development in that I was always on a team that was doing these practices. And so I didn't know what would happen if we weren't doing them. But when I started coaching and doing a lot of training, I discovered that a lot of teams are really struggling with completing product backlog items or user stories after a certain point, they, like I said, it's the kind of thing where everybody starts out with a new process and a new, hey, we're going agile, and hey, we're doing Scrum, and everything's great. What happens after a while is that people realize that they are having to change what they already worked on. They're building software, and then they're changing things that they didn't think they would have to change, or they knew they had to change it, but they're like, well, how does this whole agile thing work if I have to go back every 2 weeks and change what I wrote? What does that mean? And that's the Agilist dilemma. So I'm an Agilist. I like the idea of doing incremental and iterative development and releasing, small increments to consumers, and getting the value out of that software early and often, and getting feedback from that software early and often. So yay, agile. But the problem is that at a software development standpoint, it becomes more and more challenging because the software is getting more and more complex. And because it's more and more complex, it's more likely to break. And so software developers, what they tend to do is they tend to just really slow down. I know this from experience before Agile was around. I would be extremely careful. The more complicated the code got, the more careful I had to be. I can introduce the new feature without breaking it, but I can't introduce the new feature without breaking something else. It's almost invariably going to, there's too many moving parts in even a chunk of software that would fit on your screen. I have an example of that where people can't even, it's like unfathomable what's going on. So that's the Agilist dilemma. So the dilemma is, what do I do about this, right? And the answer is Core 4.
Awesome. Thanks, Rob. Okay, here's another great question. Do you have any tips for incentivizing developers to try these techniques with an open mind?
I'm glad this question came up. I'm very glad this question came up. It's interesting. I've coached. I've worked with executives and management, and I've also worked with developers. And it's really kind of funny sometimes. I'll go in and the management will say, how do I get my developers to do these things? And then I talk to the developers, and the developers are, how do we get management to let us do these things? And so really it comes down to time. It's a little bit expensive at first. It can take about a month. People need about a month to get good at these things, or to even sort of get the feel for how they work and how they interoperate. But also, if you're doing some of these practices, you have to undo others. Like I mentioned, pair programming and mobbing. Now, it's not necessarily by itself a replacement for code reviews. But if you're also doing, if you're doing these other parts of the Core 4, you essentially have a continuous code review. So who needs to review the code anymore, right? The code is as good as it's going to get, pretty much out of the box. So this is the kind of thing where you're recouping the time being spent in code reviews, or you're recouping the time also with, especially with test-driven development and these sort of practices, you're reducing the number of defects. So one of the things that we learn in systems thinking and theory of constraints and lean and all this kind of stuff is that if we have a defect occur in our system, what that means is that it has to go back, right? The product backlog item, or however you want to call it, has to go back in the cycle and back through again. So a defect is waste, right? A defect is going to take an inordinate amount of time to find and fix. And then if you fix it and you break something else, or somebody was relying on the broken defect, that can happen too. So there's all this feedback loop of negativity going through with defects. So if you do these practices, what happens, and I can tell you from first-person experience, what happens is that your defect count goes way down. I was just, it's been a couple of years now, but I was talking to one of the managers on one of the team's software that I built that's still running after 19 years. Running after 19 years, hasn't had a severe defect since 2003. So we're talking like years and years without a severe defect on software that's churning and changing every sprint. And these things sound like phenomenal and impossible, but they're not. They're really not. If you do these things diligently, they work. And defects don't have to be part of the game. They can be the outlier. You can't get to zero. Things are going to happen. Things are going to break, or there's a misunderstanding. But you cannot, you cannot get to perfect, but you can get really close. So going back to the question, though, I used to say something like, something a little bit offhanded, like, got to slow down to speed up. You got to give the teams time to learn these things and do these things. And people don't like slow down to speed up, and I don't blame them. What I've been talking about lately is you got to think about it as these are professional practices. They're like sharpening the chef's knives. You've got to have the time to sharpen the knives. You've got to have the time to do the right thing continuously. Otherwise, big messes build up. A friend of mine just tweeted something yesterday. Ron Quartel. He just tweeted something about a great metaphor. He said, if you were in a wood shop, would you tell the workers in the wood shop to stop sweeping? Would you tell them to stop putting their tools away? No, these are the things that we do professionally. And they have a purpose. Otherwise, things get dangerous. The thing with software is that they don't get dangerous for the software developers. They get painful for the software developers, but they can be dangerous to the user. So defects are dangerous to the user. That product that I talked about that's been running for 19 years is a life-critical piece of software, and it was built test-driven. And it was built test-driven because it was a life-critical piece of software that had to work. Right? You break it, and they used to remind us every once in a while with that sort of how shall I say, have fun storming the castle kind of thing, right? It's have fun on your sprint, but remember, if you break something, somebody might die. Well, that's enough for me. And doing test-driven development is very natural. These things are all very natural. They don't feel natural at first, but what you discover is that there really isn't a whole lot of overhead. With test-driven development, you're just writing what you were thinking anyway. You can't write a line of code without thinking about what it needs to do, what the results are going to be. So we just write the results down. It doesn't take any extra time once you're good at it. Refactoring is just thinking about design, but thinking about design from the standpoint of what do I got right in front of me? What have I already built? You look at a UML diagram that's planning 6 months out, and you don't know what that's going to look like, or you don't know whether it's going to work. Chances are it won't. So these practices are the professional practices that make sense. When software developers do them, within, I would say within a month, they will start to feel the reasons why this creates a sane working environment. So that's going to encourage them to take the time to do it. What we need to do is also change the culture, so to speak, and allow software development teams to have the space and the time, the buffer time, if you will, to explore these new practices, because they are new practices. We don't learn these in college, unfortunately. There are some colleges that are teaching some of these things now, but we don't. I still talk to people who are just coming out of many of the major universities. They've never even heard of this stuff, and I'm like, it's been around for 20 years. This is how we build software. All right, I'm rambling a little bit, so next question.
Awesome. No, thank you, Rob. And we're getting a lot of questions about pair or mob programming. I'll try to group a couple of them together, but really the heart of the matter is, how do you convince management that pair programming and other techniques like this can be really valuable? And there have been some questions about kind of the cost benefit analysis of this practice. And if you can also comment a little bit on what is the ideal size of a team for practicing ensemble mob programming?
Oh, wow. Let me answer the second one first and then go back to the first one second, if you don't mind, because that's just how I work backwards. Everything's backwards. I don't know that so I'm not the right person. I've coached a number of mobbing teams or ensemble teams, and they have a tendency to be a lot smaller than people think when they hear the word mob. 4 people, 6 people, that kind of thing. And they tend to be a little bit fluid. The sizes will change every once in a while. Somebody will hop off and work with a different mob or something like that. And I talked to a CEO of a company that strictly does mobbing, and he mentioned that there was one thing that he saw one time where there was about, I don't know, 20 to 40 people in the room, and you would think that nobody would be able to contribute as an individual with that many people, but he said it was something about doing programming on a quantum computer. And there were quantum computing scientists, and there were software developers, and there were, business analysts, and all of these different things. And they were working on this, and a mob, and everybody was contributing. And they actually managed to accomplish something because there were that many people in the room. So it just varies. I would say the right people need to be in the room. Just start out with the team that you have and try it out. A lot of this has been happening during the pandemic as well. Is a lot of people are finding that they're just going to start up a Zoom session at the beginning of the day, and everybody just joins the Zoom when they can, and everybody steps out when they have to. And invariably, it becomes a little bit of an ensemble programming where, we're just working on this one thing. Let's get this one thing working. Everybody's on, all hands on deck kind of thing. And what I like to say is that the more complicated the software is, the more eyes should be on it. Do we need business analysts' eyes on it? Do we need software developers' hands on it? All of these things. Do we want a tester involved? Well, chances are that the more critical the software is, the more people are involved in it. And then, you got to ask yourself the question, how unimportant does a piece of code have to be for one person to be working on it? And I would have to say that if it's so rote, so simple, so boring that one person can do it, why are you doing it? So let's go back to the other question, which is the justifying the, and I've got one here that was a really good one. How do we justify pair programming to a client when the cost will go up considerably? So one of the things that we've seen happen in the past is that you just don't really convey the how of the software development team to the client. You just convey, we're going to build this stuff and we're going to have it for you on this date. And with there are constraints that Agile already places on that. It's a flexible scope. Fixed cost, fixed time, flexible scope approach is the Agile approach. With pair programming, one of the things that I like to say is we talk about this with pairing, and we talk about it with test-driven development as well. Is boy, that's it's test-driven development's twice as much code. Well, actually, it's more like 3 times as much code. Pair programming, it's 2 during the work of 1. How are we going to justify that? There's an assumption there. There's a false assumption underlying that is going to take more time. And it can seem like it takes more time, especially, like I said, within that first month. A pair, I think there's academic measurements that a pair does take approximately 20% longer to do the same thing. Only then, there's the caveat that the quality of the software coming out of a pair is so much better that they spend far less time going back and fixing things. Right. So if you're including the time it takes to repair the software that is written by a single person who just gets into the weeds and doesn't notice something that somebody else is noticing, then it's not an extra cost. It's actually I found that it's anecdotal, it's empirically anecdotal, but my finding is that if I have one task and Solly, you have a task, and we can either, you and I, work on those tasks separately, or we can pair on your task and then we'll pair on my task, that if we pair, we'll get done with both tasks faster. And there's a lot of social science that goes into that. It's not so much just, the clock is ticking, we're billing hours. it's more about the social aspects of it. If I struggle with my task and I feel like I'm supposed to be the expert, what am I going to do? I'm going to go online and look at, 8 different YouTube videos and check out Slashdot and try to figure out how to fix this. All the time, Solly's like, oh, I could have told you how to do that. Or, the whole, you're just missing a semicolon on line 3. That sort of thing actually happens, and it actually pays you back in dividends.
Awesome. Okay. So we're getting a few questions also about quality assurance and how this role fits into the structure. So how do QA engineers fit best in the structure? My current team relies on QA to write test cases before development begins, and code is passed to QA for testing rather than developers running tests themselves. This seems inefficient. How can it be improved?
Absolutely, yeah. Make those QA folks part of the team. And have them write the test scenarios alongside the developers. And this is the behavior-driven development approach. Is oftentimes a tester or QA person and the software developers sitting together, working on the scenario, the test scenario, and then the developer might say, oh, that's going to take me 10 minutes to get this running. Do you want to hang around and watch and think about the next test? Or do you want me to go pair with Joe over here and you can go work with somebody else and come back, and it'll take me, if it takes me a half an hour, then yes, maybe the QA person is going to get bored silly. So this is such an important role, but it's also, the QA role is one of those roles that I think changes the most on an Agile team. Because they are not doing the testing up front, they're doing the testing as we go, and they're not doing the testing afterwards. They're not having it handed off, and then they don't become the bad guy. And so things get tested right away. The tests are written, the tests are readable, especially if they're in something like Cucumber. They're human readable, so the QA folks don't need to learn how to code if they don't want to. There was this phase for a while. It was like, well, if you're going to be a tester on a software development team, you better learn how to code because the tests are written in code. Unit tests are written in code, but behavior-driven development tests are usually written in something like Cucumber. I can't even think of anything I like better than Cucumber, so I'll just say Cucumber. No, I don't get a kickback, and it's free anyway. So it's these Agile approaches are supposed to be radically team-centric, and what we're doing is we're radically removing handoffs, right? We don't want to go from tester, here's the scenario, developers go build this, developers come back and go, here, testers, go test this. No, we just work together. Whether we're doing Ensemble or not, we're working together.
Rob, I wonder if we can actually jump back to the conversation about mob programming. And we're getting a lot of questions of now we're functioning in this distributed team environment. Do you have any tips on making this work with this new change in the workplace?
Oh yeah. Let me let's see. How hard is this going to be? I'm going to switch to sharing my browser. I might as well find out whether I can find it again. Yeah, here we go. And screen share. Google Chrome. Okay. I don't know what all is here, but there's a tiny little script called mob. I think it's mob.sh. And this is remote mob programming. What it does is it effectively lets you commit to a local repo, and then also when you hand off to somebody else who's driving. So the mobs are not as chaotic as mob sounds. There's essentially three roles. There's, just like in pair programming, there's a driver, there's a navigator, and then there's everybody else, contributors, mob, the ensemble, however you want to look at that. And there are some rules that you can apply around that if necessary, but for the most part, it's just, that's the way it is. When the driver is done with their part and they want to hand it off to somebody else, they type something into mob, the little shell, they type a command. It actually pushes their changes into, I think it's actually a separate branch just for the purpose of switching mobs, but there's probably also one that pushes to master or pushes to the trunk, right? So it has a way of handing off, and then somebody else picks it up and says, okay, mob start, I think it is, and then they're the driver. And it may, on some systems, maybe all systems, have a little timer that you can set too, so it tells you when your time is up. We don't want to exhaust the driver, so the driver is sitting there for maybe 5-10 minutes at the very most before switching to another driver. So it actually turns out to be a little bit easier online in the Zoom world than it was in person. Although it's a lot cooler in person because you have big screens and you have multiple keyboards, and it's just a lot more fun, and there's drinks and snacks.
Okay. Our next question is, if an organization has not implemented any of these practices, which one would you suggest they start with?
Oh boy. I'm thinking about an ongoing discussion that I've had with multiple people. Arlo Belshi says continuous integration first. Richard Lawrence says behavior-driven development first. I've always been a fan of test-driven development first. It would, I think it's very contextual. I think one of the things that we need to focus on is that core. How are we going to be able to refactor our code? And if the problems with refactoring our code are merge conflicts, or everybody's waiting until the end to do their merging, then maybe continuous integration is the first step. If our biggest problem is defects, I might go with test-driven development. If our biggest problem is misunderstandings and we don't know what to build, so we're building the wrong thing, and we thought you meant, the old we thought you meant, right? We thought you meant this, but you really meant that. Behavior-driven development might be more appropriate. And so I would say, think about what it's going to take to actually get things to get out the door easily, smoothly, and sanely. Not easily, but smoothly and sanely. And then go from there. So look at the heart and then figure out where your biggest pain point is. Now, having said that, let me say also that people will often go, well, it's Kaizen, right? We have to make one small change, and this is the great thing about Agile, is that we have the retrospective. We can try something for 2 weeks and then go, okay, so did that work out well? Do we want to continue it? Do we want to change it a little bit? Do we want to do a better job at it? Or do we want to drop it all together? And so we have this empirical system by which we can come back to something or try something or drop something and do things incrementally. Kaizen, like I said. The thing is, these 4 practices work very closely together, supporting each other and supporting refactoring. And when I teach test-driven development, people get pairing. They do everything in pairing. Pairing isn't something that you have to sort of establish. You just sit down together. It's not anything formal. the two P's in pair programming, I often put into lowercase because I don't want it to sound like something, that's out of the, that's in some guide somewhere that says thou shalt do pair programming. No, it's just working with your friend, your colleague on a task. Test-driven development does take a lot more work to learn, and refactoring is it's intuitive. Refactoring is intuitive, and it can remain intuitive, and it can be very powerful intuitively if you have the tests. So that's why I always say test-driven development is probably the place to start. But these things can be pulled in more than one at a time, is my bottom line there. And this is the reason why a lot of teams are mobbing now, because they're like, well, we've got this challenge. We're all working remotely. Let's just get together and see if we can get something done. And then they discover that they're really quite productive, maybe even more productive than they used to be. And they're like, well, this is just working. Why mess with what works? So it just depends.
Awesome. Okay, our next question is, in your opinion, how do you get testing to be as quick and agile as the development? At our business, we often experience issues with end users not being finished with testing in time, sometimes creating bottlenecks in the backlog.
So by end users, I'm assuming that we're talking about like a separate phase of testing, like user acceptance testing, or just user experience testing, something like that. So there can be, even with a fully agile team, there can be a gate that the software has to go through that can exist. And I suppose I would look at the whole system and what kind of things are the users coming up with, what's slowing them down. We talked about having a user acceptance test on one team, and somebody said, well, yeah, but the users have to come in for a full day and do this user acceptance testing, and we usually do it like once every couple of months, and that's every a whole day every 2 weeks is going to be too much. And I'm like, well, do they really need to come in? Do they really want to come in for a whole day? Can they come in for half an hour every 2 weeks? And it turns out that they were happy to work with the team, for an hour or half hour every 2 weeks. And so, as we shrink the amount of software that we build, because we're shrinking the time box, we have to shrink everything else. You don't do a day of planning for a 2-week sprint, right? So, right. So the same thing with all of these things. We're compacting them down. We're smoothing out and parallelizing as much as possible. This is why behavior-driven development is essentially testing software development, software design, everything all at once. It's not like we're doing mini phases. We're just actually doing it all at once. Well, if there's some of that can't possibly work that way, then yeah, it has to go off at the I'm wrong side, at the end of the system. But it has to be shorter in a sprint. I don't know if that actually addresses the question. Did we have details with what kind of issues they were having, or what kind of testing we're talking about?
So I think what you suggested was spot on. I had a comment that came in that said, yes, that was the proper understanding. So we have only a few minutes left. So I'm going to read off one more question and we'll see how we are with time, but we are nearing the end of the session. So here's the next question. If any new changes become a priority and we're at the end of a sprint and the customer wants to incorporate the change in this current sprint, what would be the strategy to move forward? Specifically, if you have any advice for how a Scrum Master can change or support that.
Okay, could you read that whole thing again for me? Because my brain blipped in the wrong direction there.
Totally.
Didn't do anything wrong, just read it again.
You got it. I'll make it as simple as possible. If any new change comes up, becomes a priority, and we're at the end of a sprint, and the customer wants to incorporate the change in this current sprint, what would be the strategy for handling this for a Scrum Master?
Yeah. So the idea behind the agile software development is, there's an old thing about Scrum. You halt the sprint or something like that, or you stop the sprint. I don't know if I've ever seen that actually need to happen. It depends on what it is. I mean, if it's like a defect, then I would say, it'd be great if we could halt the presses and work on a defect. If it's just some, hey, this is now my top priority, and you're in the middle of your sprint or you're towards the end of your sprint, I guess the question would be, what needs to stop happening? The team is going to need, if they've got, let's say they've got 2 stories or 2 PBIs that are in flight and they're not quite finished, they're going to have to take those and kind of bring them to a gentle landing somehow, either, tie them off, wrap them up, or close them out so that they're not, going to create some half-baked feature. And do we have the time? The other question is, do we have the time to actually complete this? Otherwise, just bump it to the next sprint. It's kind of a struggle for me, because it's if it happens infrequently and it's kind of urgent, like, oh my gosh, if you can get this feature out the door in 2 days, Microsoft's going to buy our company. Okay, great. Maybe we'll work on that. Maybe. But if it's happening a lot, then there's something wrong. And we need to look at it systemically and say, okay, so why are these interruptions occurring? Why do we not know what our priorities are? And the sprint, maybe the sprint is so long that, if you have a 4-week sprint and the last week you're constantly getting some requests in, it's because priorities are changing during that month. Shorten your sprint. I'm a big fan of 1-week sprints, because if you can't get anything done in 2 weeks, you can get a lot more done in 1 week. It's kind of one of those strange things. Shortening the sprint, shortening the time box, people have to figure out, well, how much can I actually get done in a week? And it's a lot. So that way, they priorities change. You come in the next week and you do something a little bit different. But it's not supposed to happen that often.
Awesome. Okay, so we only have a couple minutes left, so we're going to actually go ahead and end the Q&A there. Thank you all so much for those questions. This has been so exciting to see the engagement and the response that we've received. I want to share that I'll compile the remaining questions and share them out with Rob, and hopefully we can get some responses to you that we share out on our resource library on the Scrum Alliance website.
Sure. Thank you.
Awesome. Thanks, Rob. So we'll go ahead and close out the event. Just a couple items before I close out the Zoom. Thank you again to our presenters, Jorgen and Rob. 1 second. There we go. And thank you all again for attending and your engagement and your questions. As a reminder, we'll send a follow-up email after this presentation, and there you'll be able to find the recording from today's session, as well as instructions for how to find the tool in your membership dashboard. Also, if you're a certificate holder, this session is valid for SCU credit. I'm going to share a link right now in our chat. If you click on this link or copy and paste it, you'll be able to get automatic SEU credit for attending today's session. And we'll also send this out in our follow-up email. So with that, that's really it. Thank you all again for joining us today, and have a wonderful end to your day.
Thank you, Sally.
Thanks, Rob. Thanks, Jorgen.
I think Jorgen might have fallen asleep.
All right. Thanks, everyone.
Ah,
For that
there he
SEU
is.
link.
Bye.